greetings of the day. This is Pawan, Maths faculty here in Global ITNs. Today we are going to discuss very important concepts and tips in covering all the Term 1 syllabus. First chapter we are going to see the relations and functions. Most importantly, in relations and functions, there are some questions like 1 mark questions being asked. Number of reflexive relations, number of 1-1 functions, number of on-to functions, number of bijective functions, and types of relations. So we are going to see this type of questions, how to easily solve them. For example, I will give the basic concepts for these relations. So when two set A and set B are given to you, and number of elements in each set are also given to you, n of A, n of B. Now, what is a relation means? Relation is subset of A cross B. This is the basic definition we know. A cross B, what is A cross B? It is formation of ordered pairs, A comma B, where A belongs to A, B belongs to B. So, number of relations will be number of subsets for this. How many elements will be there in A cross B? N of A cross B, that is N of A into N of B. So, how many subsets we have for A cross B? 2 power N of A into N of B. So, this is the first one set of questions may come regarding number of relations. Number of non-empty relations means we have to just subtract -1 from this. Next important concept is in types of relations. There are many types of relations: void relation, universal relation. So we are going to see the relations which are coming in both. Mostly they are asking about reflexive, symmetric, transitive, equivalence relations. So what is a reflexive relation means? We have ordered pairs in a relation. Now the relation we are defining in set A, which is having n of A elements. Reflexive relation means if n of A is equal to, if I take example, set of 1, 2, 3. Now I can make ordered pairs for A. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 3, 3, 1, 3, 2, 3, 3. So now we can take any subset of this ordered pairs. Now a relation is said to be reflexive when A comma A belongs to R for all elements in A. That means 1, 1, 2, 2, 3, 3. All the elements, if they are there in the relation, then that type of relation we can call reflexive relation. How many types of reflexive relations are there? That is given by formula 2 power n into n minus 1. In sample paper many places been asked number of reflexive relations. It becomes 2 power n into n minus 1. Next, symmetric relation. What is symmetric relation means? In relation, if there are ordered pair A comma B, if you have defined, then definitely B comma A should be there. That type of relation is called a symmetric relation. Next, coming to the transitive relation. If you define A comma B and B comma C, then definitely A comma C should be present in the relation. If you don't define A comma B, B comma C, then it will automatically we can say it is a transitive. Here also in symmetric also, if you define A comma B, then you have to search for B comma A. But for reflexive, all the elements A comma A should be defined. I'll give an example. See, if A is equal to, if R is taken a relation 1, 1, 2, 2, 3, 3. So what type of relation is it? It's been asked. So what type of relation, if you see 1, 1, 2, 2, 3, 3 is a relation in A. So all the 1, 1, 2, 2, 3, 3 are present. So we can say this is a reflexive relation. Now whether it is symmetric or transitive or not, 1, 1, 2, 2, 3, 3. See, if you take 1, 1, what is the B comma A? 1, 1, 2, 2, 2, 3, 3, 3. So this is symmetric also. The last one, is it transitive? Yes, it is transitive also. So this is one example where it is all reflexive, symmetric and transitive. So if it is satisfying all these three relations, we call it is a equivalence relation. Okay students, only for, the main thing you should remember is only for reflexive, all the elements should be defined. 1, 1, 2, 2, 3, 3. All the elements in A should be defined, A comma A. But for symmetric, if A comma B is defined, then we have to search for B comma A. Okay. So next, coming to some of the questions with the examples. The example 1 I am taking here, x minus y plus root 2 is a relation xy, x comma y belongs to real numbers. Is given whether it is x minus y plus root 2 is a irrational number. Is the relation, what type of relation is it? So the first one we are trying to find is whether it is reflexive or not. For reflexive condition, what we do, we substitute the same element x comma x, we take it and we see whether it is satisfying a irrational condition or not. If I take x comma x, x minus x plus root 2, we get root 2. Root 2 is an irrational number? Yes. So we can say it is reflexive. Coming to x comma y, is it implying y comma x? So students, you have to remember one thing. There is no need to prove a type of relation just by one example. Theoretically, if it is satisfied, then we can conclude it is a relation, that type of relation. But if one example is there where it is not satisfying that type of relation, we can conclude it is not that relation. For example, there are many examples you can say where the symmetric principle is satisfied, symmetric relation it is satisfying. But for one example I am going to take, root 2 comma 0, many examples you can take, root 2 comma 0, 0 comma root 2 you take it. Root 2 comma 0 when you take it, root 2 minus 0 plus root 2, we get 2 root 2 which is a irrational number. Okay. Next 0 comma root 2 if you take it, 0 minus root 2 plus root 2, how much it becomes? 0, which is not an irrational number. So we can say this is not symmetric relation. Got it? Next, moving on to the next one, transitive relation. Same a comma b, b comma c, then c comma a should be there. Now if you see here, root 2 comma 0 if you take it, root 2 minus 0 plus root 2, 2 root 2 comma 0, 2 root 2, we can say it's irrational number. 0 comma 2 root 2 if you take it, 0 minus 2 root 2 plus root 2, minus root 2 we get it. Minus root 2 is also irrational number, but root 2 comma 2 root 2 if you take it, how much are you going to get? Root 2 minus 2 root 2 plus root 2, 0. This is not satisfying. A comma b, b comma c is not implying c comma a comma c. So this is not a transitive relation. For an example, so this is one example being asked. This is a little exemplar level. Next, moving on to one more example. A relation is given, family members x, y. X is brother of y. What type of relation is it? If we take reflexive x comma x, x is brother of x. No. X is brother of y. Is it implies that y is also brother of x? No, not always. Y can be sister of x also. So it's not symmetric also. Next, if x comma y means x is brother of y and y is also brother of z. Can we say that x is brother of z? Yes. This is only transitive. So this example gives it is only transitive. Next, moving on to the what are types of functions we have. Next, what are the number of functions? This is a very important question is coming. So we will go to the next examples. Moving on to the few more concepts in this chapter, relations and functions. First, here we are going to see about functions now. In functions, a relation will become a function when all the elements in the domain they have a unique image. Not more than one image they should have, and all the elements in the domain should have an image. So then the relation will become function. So a number of functions from A to B. If n of A is equal to m, n of B is equal to n. Number of functions will become codomain power domain. This is called domain, this is called codomain. So it becomes n power m will be number of functions. Okay. Next, there are types of functions we are going to see. One function, onto function, bijective function. The one function is also called as injective function, and onto function is called surjective function and bijective function. So what is one function means? No two elements in the domain have the same image. So we can say in the different way, f of x1 is equal to f of x2 is possible when x1 is equal to x2. So in this way we check whether the function is one or not. Graphical way of checking is when you draw a line parallel to x-axis. If it doesn't meet the graph at more than one point, means if it meets only at one point, then we can say there is one function. If it meets more than one point, then it is not one function. For example, f of x is equal to x square if you take it. Is it 1? No. Because if we take f of 1 and f of minus 1, we're going to get the same value. So positive and negative values are having negative integers having same values. So So this type of functions, they are not one-one functions. If we take f of x is equal to x, so what type of function is it? Is it one-one or not? Yes, it is one-one function. Okay. So here we can say it is one-one function. Next, moving on to the onto functions. What are onto functions means? If range is equal to codomain, means there is a domain codomain given to you, and set of all images we call it range. So all set of all images, the range is equal to codomain, then we can call it as onto function. So onto function, number of onto functions. This is a bit lengthy formula, but mostly in boards this level is been asked. N of A is given m, n of B is 2. Number of onto functions from A to B become 2 power m minus 2. Okay. So this way we can do number of onto functions. Next, what are bijective functions? Means the function which is both one-one and onto functions. They are called bijective functions. So number of bijective functions is possible only when both number of elements in domain and codomain should be equal. If they are equal to n, the number of bijective functions we can define is n factorial. Got it? So this is the number of bijective functions. Next, moving on to one example, check whether the given function is one-one or onto. So f of x is given x square minus 8 divided by x square plus 2. So check if it is defined from real numbers to real numbers, check whether it is one-one and onto or not. First, you take f of 1, you get 1 minus 8 divided by 1 plus 2. Minus 7 by 3 you get it. Next, f of minus 1 also get the same value. So that means two elements are having same image. So what we can say, it is not one-one function. Next, coming to the onto function. In onto function, what we have to check whether the range is equal to codomain or not. So here, if you see how to find the range in the grade 11, we have studied that. Equate the given function to y, write x in terms of y. Then find the domain of y. So x square minus 8 divided by x square plus 2 is equal to y if you take it. If I simplify this one, x square minus 8 is equal to y into x square plus 2. So x square into 1 minus y is equal to 2y plus 8. X value we get root of 2y plus 8 divided by 1 minus y. Now find that what is the domain of this one. Y can never take 1. So one example you can give if it is not onto function. So if I take y value 1, means when I equate f of x is equal to 1, for which value of x it comes 1? Check once. If we equate to 1, no value of x, we can make it 1. So it is not onto a function also. So this function is neither one-one nor onto. Got it? So these are the few concepts we have seen here in the first chapter. Thank you so much, students.